Hi, welcome to my channel about robotics, physics technique and embedded systems. This video is focused on my ESP32 right here, connected to various electronics and two motors, physics technique motor and a servo motor, ST90, both driven by pulse modulation. And this one is standing loose, so it has nothing to do with this video. Last time I was trying to get this circuit working, which is driven obviously by the ESP, and via this switch driving this LED. So far no luck, but I'm trying once again to see what's going on, what's going wrong and how to fix. And for that I switched to screencast to show you everything I can. With this screencast I have several programs opened. First of all, the Arduino programming environment, which I use for obviously the C code to control it. Then the serial terminal, also from the Arduino environment. Then various options. I have not this one, but this one, Scilab, a numerical mathematical program which is also capable of simulation, and in this case, as you can read, BC588, which is the transistor, the PNP transistor, which is, and then I have to get rid of this window, which is this one actually, ready to simulate and see whatever the outcome is. Then Fritzing with all wires, and of course circuit with the ST90, and this is depicting the physics motor. Then the gEDA editor with the whole setup of the schematics, and obviously the camera. So where am I right now? Well, nowhere yet, because I haven't uploaded the program into the random access memory. So let me do that first, see how things respond, and then also connect the multimeter to the circuit to measure any voltage uploading and see what happens. So now everything has been applied. The location of the motors have been changed a little bit in order to get the multimeter readable by the camera. And next, when you see this LED light, this should light up as well, which it clearly does not. So there's a problem. Is it the transistor that I don't have a replacement for, or whatever it is? Let me just do a measurement right here. And the needle moves. That means that indeed we have voltage over there. Next round here should be a voltage being measured. Well, there is 4 volts. This is nothing, but this is the controlling. This is the control. This is always there. So here should be something as well at that moment. And right now it shows nothing. So let's go and try to visualize in the simulation. And then this is the simulation, and so it is quite confusing here. But if I move this down, then you will see whatever is intended to be. So I'll try to get this done pretty quickly. Just go here, then and then this block should go over here. At least now things get a little bit more clear, which is which, and alright, so these lines don't intersect, they are just there, and this means that the output signal from this voltmeter is the input to this oscilloscope, which is driven by this clock. Then this switch is driven by this pulse generator, which is driven by this clock. This switch gives the control voltage to this transistor, which is fed by this voltage of 1.5 volt. Anyway, let's see if this actually wants to run, which it doesn't, which is too bad, syntax error somehow. Maybe it helps if I make a new simulation drawing. I have now recreated one of the simplest schematics, just a power source, voltage unit, oscilloscope and clock. And what happens is the same thing. So this is with version 6.1.1. I thought, well, I have version 5.5.2 as well, recreating exactly the same thing, and what happens is a nice graph. So there might be something going on with version 6. Now let me recreate the whole thing again in this version, see what ever happens next. I did recreate the schematics in version 5.2.2, and although it looks different, it is the same circuit, same values, and unfortunately, although everything seems to go fine with this, nothing is recreated, I get an error somehow, which I can't reproduce now, of course, but there's nothing shown. So it is a little bit better than this version, but there is still something in the circuit what is not intended to be, clearly. So simulations are nice, but they are dependent on settings. Anyway, how to proceed? Because I'm still no wiser. Next thing is going back to practice, and then there is something that I did not see first in the example schematics on the internet, and a description tells that it is always recommended to have a resistor right between the switch and the base of the transistor, which I clearly do not have. So in order to show that precisely, between the switch and the base there should be a transistor, and same thing here where I added a transistor, a resistor that is, of course. So the question is, why should that be there? Well, as they say, it should be there to limit the current, because that's why there is a resistor, and a too high current may damage. And I think my transistor is damaged. And by the way, it's not the 588 but the 558, which you can easily find on the internet specifics if you're interested. But well, since I do not measure anything here where it leads to this LED, I think I've tried it by not adding the resistor in the first place. Which means the end of this, and the simulation didn't end up very well either. So where to go from here? I could always order a new transistor, the BC558, but well, practice tells me that shipping and handling is way more than the transistor itself, so I'm not doing that for now. Leaving out this one with a kind of monstrous switch, by the way. Yes, it is way too large. There may be other things to do, among which is another attempt, perhaps with this microphone. I'm not quite sure yet. But the ESP32 is a multifunctional device. I could try to do the real base C programming in Flash, which I have done in the past with mixed effects. So who knows what comes next, but this experiment with this transistor is over for now. Thank you for watching. If you like this video, please do subscribe to this channel, give the video a thumbs up, click the bell for notification, leave a comment or suggestion, very much appreciated. You can also follow me via Twitter and Instagram, and you can also support via either PayPal or Ko-fi or by becoming a patron. This is going to be continued with some other experiments other than that one. So stay tuned. For now, have a great day, stay safe, take care, bye.